So we are now going to be doing lesson 1.3, and I'd like you to actually go to page 12 in your workbook and pause this video and try number 5 and number 6 and try those on your own, and then when you come back I'm going to walk you through how to do those too. So pause your video right now, please. So hopefully you actually paused your video and you tried those on your own. So what we're doing here is we're solving an equation. And when we look at this at first, what we realize is we have a distributive property. So we need to multiply using distributive property. So I'm going to take 5 times 2x, which is 10x, plus 5 times 6, which is 30. And over on this side, we just bring down what we have. Now hopefully you remember that when you were in 7th grade math, if you have variables, okay, on opposite sides, or terms that are like terms on opposite sides, you have to move them to the other side. Now you were doing that when you had the equation, let's say 2x plus 15 is equal to 21. You knew that you had to take and move the 15 over with the 21 because they're like terms. And what did you do with that? Well, you subtracted, or you added the opposite. You did the opposite of what you had. We have addition, we're going to subtract. So we're going to do the same thing even with variables. So if we're going to move them, we have to do the opposite operation. So right now, and sometimes it looks like what we have to do is we have to just pay attention to how do I get it to go to 0. So if I have 8x, how do I get it to go to 0? Well, I'm going to subtract 8x from both sides. Okay? So I have 2x plus 30 is equal to 48. And I really recommend that you always start with the variables. You can start with anything moving it, but if starting with the variables, that will come into play later on with some other equations that we're going to be looking at. Okay, so now let's just solve the equation like we have been doing. We're going to just move the 30, so we're going to subtract 30, and we get 2x is equal to 18. Divide both sides by 2, and we get x is equal to 9. Okay, let's do the same thing with number 6. We're going to distribute to begin with, and so we're going to take negative 3 times 8 and negative 3 times 2 times 3h. So we get negative 24 plus negative 9h is equal to 5h plus 4. And again, you can start with anything. You have to pick something and move it. And I recommend you always start with moving the variable. So I have a negative 9h, and you can move it to either side. I have a negative 9h, so in order to make it go to 0, I'm going to add 9h. So I get negative 24 is equal to 14h plus 4. Now our like terms happen to be the numbers. So I'm going to move the 4. So I'm going to have a 4, I'm going to subtract a 4. So I get negative 28 is equal to 14h. Dividing both sides by 14, I get that negative 2 is equal to h. Now something we haven't done a lot of is to check our answers. So I'm going to take and check this answer, and I'm going to check an answer, I just have to take my solution and plug it back in for my h. Okay, so here we go. Here is our check. And what we want to do is we want the sides to match. So I have negative 3 times 8 plus 3 times h. And h here happens to be a negative 2. And then I have an ending parenthesis is equal to 5 times h, negative 2, plus 4. Now I just have to get these sides to match, so I'm just going to simplify each side. I'm going to start with the right. Negative 2 and 5 is negative 10 plus 4. That gives me a negative 6. Over on the left-hand side, I have a lot more that I'm going to simplify. So negative 3, 8. Now I have 3 times negative 2. That's a negative 6. So negative 3 times 8 plus negative 6 is going to give me 2. Negative 3 times 2 is negative 6. They match. Once they match, we know our answer is right. And this is always a good idea when you're solving equations to check your answers. Now I want you to go to page 9 of your book. And I want you to try this problem. I want you to just think through it and try it on your own and see what you come up with. Okay, so especially A and B. So if you want to play with that a little bit and try those. Thank you. Pause your video. So one of the ways I would approach this problem is I would say, hey, let's make a table for theater A and theater B. And what I'm going to do is I'm going to say number of friends and cost. Now, what you're going to have to realize is that you're going to have to, in order to do the equation, you're going to have to say, I have to take, and here they are really vague, just some friends. So that's the reason I decided to make a table. I'm going to start off, it said some friends, so I'm going to say I'm taking 2, then I'm taking 3, and then I'm taking 4. But the cost includes 3 tubs of popcorn. So you're going to have to take the ticket price times the number of friends, but you're going to add in 3 tubs of popcorn. Now, the 3 tubs of popcorn never change, so I'm going to come over here to my table, and I'm going to find out how much is 3 tubs of popcorn. So I'm going to take 3 times 575, and I'm going to get that to be something that happens every time. That's 2, and then 6 times 0.75 times 3, and I'm going to get 20.25. Okay, so that's going to always be added in. So I'm going to have 2 friends is what I'm going to start with, and 2 friends times 1450, that is equal to $29 plus $17.25. And then I'm going to do 3 friends, so I'm going to take 1450 times 3, which is 43.50, plus that same 17.25. And then I'm going to take 4 friends and get 58 plus 17.25. Okay, so let's find out those amounts. So 29 plus 17.25. 43.5 plus 17.25. 58 plus 17.25. Okay. Now, I want you to do the same thing with B. You're going to use the same kind of formula. You're going to take the number of friends times the ticket price plus 3 popcorns. But this time you're using this for popcorn and this for the ticket price. And I want you to pause and make that. So we've made a table, and now we can compare. We can compare so far anyway with 2, 3, and 4 friends. And I'm going to tell you what we're going to do. So far, if you compare, you can see that this is a 46. That's going to make a difference right here. Okay, so if I compare 42 friends, I'm going to have that they are the same price for 2 friends. At 3 friends, though, it gets cheaper to go to the theater B. And at 4 friends, it's cheaper to go to theater B. So it makes a difference on how many friends you have. So which movie theater should they choose? Well, if 2 friends, it doesn't matter. More than 2 friends, go to theater B. Okay, because it's cheaper. Good. So for what situation would the total cost of each theater be the same? Well, we found out that it was at 2 friends. 2 friends, it was the same exact cost. Two friends or 2 people. Okay, So now on C, it says, there are different methods to solving this problem. Which do you think is the best? Why? Well, I only used one method. So another method would be that you just take numbers and you plug it in right here. Okay, but one of the things that's really important is anything that we can find what's called a constant for before we begin, it just makes it a little easier. But that just gets your mind thinking. These next two problems are not in your book, but I do want to go through them first. So I would find some room on page 9 or the left-hand column of page 10 in order to do these problems. So again, what we're doing is we're solving equations where we have variables on both sides of the equation. So this is what we call variables on both sides. Okay, and my recommendation is always start with the variables. So simplify and start with the variables. So here we go. We're going to combine like terms. We get 7x minus 10 is equal to, now here we have to distribute, negative 2x. Oh, watch your signs. I have a negative times a negative, so that's going to be a positive 8. Then I'm going to continue to what I call clean up the sides. So I'm going to combine like terms on the same side. When they're on the same side, just combine them. When they're on opposite sides, do the opposite. I'm going to now work with the variable. You can choose the 7x or the negative 2. It honestly doesn't matter. I'm a person who likes to keep everything positive because I lose negatives, so I'm going to move the negative 2x. And in order to move that, I'm going to do its opposite. So I'm going to add 2x to both sides. So now I have 9x minus 10 is equal to 17. I'm going to add 10 to both sides, and I get 9x is equal to 27. Divide by 9, and I get x is equal to 3. Now we're going to go to the second one, and we're going to take 1/2 times n and 1/2 times 4. So I have 1/2 n minus 2 minus 7 is equal to negative 2n plus 6. Now we could have cleared fractions. We could have started by moving the 7 first. So if we come over here, we could have moved the 7 first, and then we would have had 1/2 times n minus 4 is equal to negative 2n plus 13. And then we could have cleared the fractions. Okay, so we can do this lots of different ways. Always look to see what does your brain see and start with it. So just to show you what could have happened here, I could have then cleared the fraction on, and notice that I'm multiplying. This is all one term because it's connected by multiplication. So I could have cleared my 2's, and I would have had n minus 4 is equal to negative 4n plus 26. And I could have solved that equation. Both of these will give me the same answer. Okay, so now I'd like you to, so we're going to continue solving this one. 1/2 n minus 11 is equal to negative 2n plus 6. Me personally, right here, I'd clear my fractions if I hadn't already done it. So I already cleared them over here, but now I would clear the fractions here, multiplying every term by 2. So I get n minus 22 is equal to negative 4n plus 12. And so now I'm going to continue with that one. So I'm going to move my variable. I'm going to add the 4n to both sides. I'd like you to pause now and finish that equation. And when you came back in, we're going to look at this equation, but I would have also finished this equation right here. Go. While you were gone, I found a mistake. This should have been a 7. So therefore, this would have been a 9. And then this would have been an 18, which will make a total difference in my answer. Okay, so then this would be 18, and then I would add 18, and I'm writing over the top so you can see where my mistake was. Therefore, this number is 30. Okay, and I knew I had a mistake because I was coming over here. So that's the reason. Write more clearly, Mrs. Phipps. Okay, so n is equal to 6. So that is solving equations. You're now going to look at the two that are in your book. So now we're going to solve these two equations, and you're going to start off by distributing. So we're going to take 100 times z and 100 times 0.2. Remember, keep in mind that that's a negative. And do the same thing over here, and we're going to distribute. So now when we distribute, we get 100z minus 20 is equal to negative 50z minus 8 or plus a negative 8. I'd like you to try finishing this equation, and because I want you to just decide yourself which one are you going to choose, because it doesn't really matter. And when you come back, you'll see that I have done the equation twice. I will have done the equation twice, so you can see it doesn't matter what you choose. So I'm going to do it more than once. Okay, go. So I did this equation starting from 3 different points because I want you to see that it doesn't matter where you start, you're still going to get the same answer every single time. So on the first one, I moved the 50z. On the second one, I moved the negative 100z. And on the third one, I moved the 20. It doesn't matter which way you start as long as you do it correctly. So keep that in mind while you're doing it. Now on B, when you look at B, do you want to clear the fraction first or do you want to distribute? It doesn't matter. What does your brain see? For me, what I look at is I'm like, does 8 go into 16 and does it go into 24? Yes, it does. So I'm not going to clear the fraction because the fraction will clear when I multiply because I can simplify right there. So I'm going to distribute and I'm not going to clear the fraction because I just kind of I looked at that. So when I multiply here, notice my 8 cancels. So I'm going to come over here, 5/8 times 16. My 8 cancels and I have a 2, so I get 10d. And then I'm going to take the 5/8 times a 24, divide by 8, divide by 8. I get a 3 times 5, which is 15. Now I'm just going to distribute. Okay, and again, go with what your brain sees. So for me, I'm going to clean up the sides next. You might see that you're going to move the 6D next. All of them are good. Go with what you think. I'm going to pause. We're all going to solve. Go. I ended up with D being equal to negative 5. So if you didn't, go back and look at my work. But notice that my way I solved it might have been different than the way you solved it, which is just fine. So now we're going to look at a word problem that uses variables on both sides, obviously. So how many pounds of Arabica coffee could you mix with 5 pounds of Robusta coffee to make a coffee blend that costs $12 per pound? This probably sounds very similar to what we did with our solution problems because it is. So what we're talking about is, and always kind of symbolize in words just to keep your mind with what is happening. It's just words make a lot of sense. So we are taking the Arabica coffee and we're adding it to the Robusta coffee to make the blend. Okay? And we want to know how many pounds. So N is going to be, not equals, is going to be the number of pounds. So N is the number of pounds. Okay, so let's put in what we know. Notice we had to have these 2 bits of information. This one is in your book. There was another one that was not in your book, but I think we can do just one and be fine. So for the Arabica coffee, it's $28 per pound. Do we know how many pounds we have? No, we don't. Because the only thing we know for pounds is how much we have for the Robusta. So for this one, it's the number of pounds of Arabica coffee. Okay, so that's the number of pounds. That's our N. Well, what is going to be the price of that? Well, it's going to be 28 times the number of pounds. So we have 28 times the number of pounds. The Robusta coffee, we do know the number of pounds. So that's going to be 875 times 3. But here's the thing with the blend. We know that it's going to cost $12, but how many pounds? Well, you have to go back to right here. You're mixing X pounds with 3 pounds. So you're going to take X plus 3. Okay? Because you have to find out what you're doing is you're always taking the cost by the pounds. Well, we didn't know how much for Arabic, but we knew there was 3 for Arabica, sorry. We knew there were 3 for Robusta, but for the blend, we know that it's the 2 mixed together, so it's X plus 3. Okay? This is where if you're in class, I'd say pause, look at that, make sure you have any get it, and if not, ask questions. Okay, now we're just going to solve this equation. So 28x plus 8.75 times, why did I put 3? It's 5. Okay, mistake. So that's where you might have been going, hey, wait, where did you get that? That should be a 5. So we're going to take 8.75 times 5, and I have the 8.75 times 5. That will make more sense. $43.75. And we're going to distribute here. Okay, now we have an equation. I want you to pause it. I want you to solve it on your own. Go. Okay, so first off, I want to point out that I made a mistake. I had put 5 over here, but I had not put 5 over here. So the number in green. And I knew I had a mistake because I was coming up with a negative number right about here. So I was like, okay, where's my error? So always kind of use your best judgment on that. So I apologize for the mistake. Okay, so here's what I got. I got 1.0156, blah, 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 blah. So we can't just leave that. We don't want to go back to the fraction because this is a word problem. We can't go and ground 16.25 divided by 16 pounds. So we have to rewrite it. So now we're going to just approximate. And I guess at this company, they can go to the nearest hundredths place. So we're going to say approximately 1.02 pounds of Arabica coffee. Okay. Good. Okay, now let's go back and actually try some more problems. These are in your book. They are on page 12. So here we go. Number 7, I want you to start off solving that. Go. Okay, did you get to this step and go, hey, wait a second, that looks the same on both sides. What's going to happen? Well, you always want to start with the variable when you're doing these, is my recommendation, because of situations like this. So what's going to happen now is that you're going to move the 2y. If I move it, I'm going to subtract 2y. Well, look what happens. We then just have my variables will add to 0 is what mathematically I'm saying, but non-mathematically they just drop out. Okay, so after your variables add to 0, you're going, well, wait a second, negative 12 does equal negative 12. So yes, that is true. When that is true, what this is called, it is called an identity. And an identity means that it looks the same on either side. If we pretend that the equal sign is a mirror, when I look into it, I see my exact same identity back out of it. So, and what that means is that it's going to work no matter what. So if you get a true statement, it's going to always work. Now, this book has you write identity as an answer. A lot of books will have you write many solutions because that's what's happening. You can plug anything in for y and you're going to get a true statement. So you have infinitely many solutions. Infinitely many solutions. So this is what this book is asking for. This is what I'm used to answering. I will take either. I am pointing this out though because I don't know what your next math teacher will take, so I want you to be familiar with both. You can put identity or many solutions. Both are correct. Good. Let's go to number 8. Okay, so start off by distributing. This first side just kind of hangs out and we get 8x minus 8. Okay, we start the exact same way here. We're going to follow my recommendation, at least I would suggest that, and we're going to move the variable first. And when I do that, I get negative 8x. I'm going to add negative 8x on both sides, so I get negative 4 is equal to negative 8. When I have 8x plus negative 8x, they add to 0. And again, add to 0 is what I have to say mathematically. What your brain is going to see is they drop out. They are gone. They add to 0. There's nothing left. So now you're looking at this and you're going negative 4 equals negative 8. And you should be going, no, it doesn't. That's your big clue. Okay? Because sometimes people have trouble remembering, is it many solutions, identity, or is it no solution? So what you want to use is look at it and go, well, negative 4 equals negative 8. No. So it's no solution. Okay? This is you have three options of what equations are going to be. One of them is that you can get one solution. That's what we've been doing up until right now. The second one is that you can have no solution, or you can have many solution. Okay, which is also called identity. So those are your three options. If I come up with a true statement, it's many solutions. If I come up with a false statement, it's no solution. But again, just look at it and go, look at these and go, yeah, that works. Yay. If it works, that means, yeah, I can have lots of different solutions. Yay. If it doesn't, if I come up with a no, that's no solutions. Good. So right now on page 11, I would like you to write down how can you determine whether an equation has infinitely many or no solutions. And I'd like you to give your ideas there. Go. Yes, you can use the notes that we just wrote down. That'd be a great idea. So you could have written lots of different things here. You could have said, hey, if it's a true statement, then I'm going to have the same number on both sides. It's an identity. Okay, so if I have a true statement, meaning that I get the same number on both sides, then it's going to be an identity. If it's a false statement, meaning I don't have the same numbers, then it's going to be a no solution. Okay? So if you didn't get that all written down, or if you want to change it, but you can pause the video and do that. So we're going to distribute. And when we do that, we're going to get t minus 27 is equal to negative 27 plus t. Okay, so let's go to the next one. It is very similar to this one, but this one is in your book. So it's 95 cents per song, just like we had before. That is his new one. And now it's going to be $15 for a joining fee, and it's 80 cents per song. So I'd like you to try this one, set it up, and see how it works for you. Go! So this is what your equation would look like, is 95 cents times the number of songs is equal to 15, because it's a joining fee, plus 80 cents each. And we're going to solve that equation now, okay? And then we're going to come back and answer this question. Go. So hopefully you came up with x is equal to 100. If not, pause yours, go back and check your work. So the question is, at what number of songs does this new service become a less expensive option than Cameron's current service? So it is when he buys more than 100 songs. When he buys more than 100 songs. Okay, so he can change over, but that means he's going to buy lots of songs in order to do it. Great. This word problem, I believe, is on page 12 of your book. So go to page 12 in your book and look down at the bottom right-hand side, and you should see this problem. For how many games is the total cost of bowling equal for the two bowling? So when are they the same? Okay, so what is it we don't know? Well, we know one pair of shoes. That's going to be a 1. But how many games? So for how many games, that's our variable. X equals the number of games. N-O dot means number of games. Okay, so let's set up. We have family bowling, and we have night owl bowling. Okay, and I want you to pause and set up those equations. Did you have 4x plus 1 equals 3.75x plus 2? Great, because what I did is I don't know how many games here, so that games here is $4 and here is $3.75, but that's what I don't know. Okay, solve that equation, go. No matter what you started with, you should have come up with 4 for x. 4 is equal to x. So what does that mean? For how many games is the total cost for the equal for the two bowling? So 4 games, it is equal. For 4 games, the bowling alleys would be equal in cost. Okay, good. So on page 12, question number 1, the essential question. And what this essential question is asking us is, what's the whole point of this? Well, the whole point of this is we want to be able to compare two things. So how do you rate them? You compare. So this is talking about if we have word problems, you compare two items, two situations, and see when it's true, and see when they are equal, and determine, that would probably be a better word, and determine when they are equal. Why does it make sense to describe an equation that has infinitely many solutions as identity? Okay, so the reason it makes sense is because that's saying that anything will work. Okay, anything will work, and so it's an identity. It's 5 equals 5 no matter what you plug in, or it's 12 equals 12, and it's an identity because they are the same thing. An identity means that it looks the same. If you identity property is multiplying by 1. So why does it make sense to describe an equation? Identity makes sense because the two sides show an equivalent number, the same number. Which is all about identity, is that 5 is equal to 5, 12 is equal to 12. Okay, anyway, going on. Isabel says the equation x minus 2 is equal to negative x minus 2 has no solution because a number can never equal its opposite. Well, we're not looking at the number because we have that 2 on there. And when it says to explain, what we can do is we can just take the equation and we solve it. So x minus 2 is equal, distribute that. Remember, you can always put a 1 right here and distribute that. So that's negative x plus 2. When I go to move my x's, okay, if I'm going to move it to the left, it doesn't matter which way I move it, I'm going to get 2x minus 2 is equal to 2. And then I'm going to add 2. Now I am going to get a number, so it can't be a no solution. And this is the reason you should never assume until all the variables have dropped out. And you can see the variable did not drop out, so you need to get it all the way down to the bottom. Number 4, you are solving an equation with a variable on each side. Does the side on which you choose to isolate the variable affect the solution? Why might you choose one? So the answer to the first question, does it matter which way you choose it? No. Just do it correctly. So it does not matter what you start with when you go to solve if you have a variable on both sides. Why might you choose one side over the other? Well, for Phipps, it's because I avoid negatives. I like to keep it positive. So I'm always going to move the variable to keep it positive. It might be because you just want to make it easier for yourself. This is my reason. You write down your reason. Okay? Why do you want to choose what you do? Maybe it could just be because that's what your brain sees to move first. It doesn't matter what you choose. This is solving equations. We've already done that. So we have done all the other problems already at some point through this lesson. If not, we've had enough practice. But I do want to point out one other thing that's going to probably come up in your homework is an isosceles triangle. What an isosceles triangle is, it is a triangle in which two sides are congruent. These little tick marks mean, hey, we are equal in measure. So if this is 45, then this is 45. Okay, we don't know what it is, but we just know that they are equal in measure. Okay, that's going to play into it. You also need to remember that if I want to find the perimeter, I'm going to add all the sides, or I'm going to delete all the sides, okay? So I'm going to add these two sides that are congruent plus this third side, which is not congruent. Don't make that mark there. Okay, so just add all three of your sides together. Good, just wanted to let you know, isosceles triangle, two sides are congruent, and they're marked with these tick marks. Great. If you'll now go work on your homework, that would be awesome. Thank you.